My talk is about observability monitoring, and pretty much building like a modular observability of AI systems. So thank you very much for attending. So yeah, my name is Gev. I'm a co-founder at AimStack and also author of an open source project, AIM. Some of you may know it's an experiment tracking tool, one of the performant ones out there. So for the last 2 years, we have been working on it, and actually this morning we launched the new stable version, a major version, which turns AIM into a little bit different tools, which I'm kind of excited to talk about today. So today's agenda is a little bit packed in that sense. So the first half, we are going to talk about pretty much like a general, like what's the state of the observability now? Like what are the needs of observability in AI systems? So kind of what are the issues we have seen for the last few years while working on AIM, while working with a number of teams, actually quite a lot of teams. So, and then kind of do a little bit of a detour of like software logging and like what kind of path we have gone through from logging software and now logging this kind of software, like large language models, like in production or like in development, right? And then the second part will be around our work on AIM. It will be around what it means, like modular observability, right? I'll go through. I'll kind of try to explain why do we need the modular observability for the AI systems we build. And then we will just talk about what are AIM apps, what it means combining them, and why it matters. So for the last 10 years, we have been building AI, and so about like 5 years ago, a lot of the activity around AI have been, around the hiring quite a number of data scientists to build some, models through your, company data. And that kind of activity has been around mainly, gather data, build a model, and try to potentially deploy it and somehow evaluate it. And then we kind of expanded once some of the companies figured out how to deploy those models, and then, then the transformers came about, and then the last 1.5 years we have been really taken away by this kind of new the LLMs, the GPT, right? All these kind of layers that we are building on top of these models. And so pretty much the amount of stuff that we had to build, horizontally grew and grew and grew over time. And now in order for us to build like a larger systems, we sort of kind of need to also care about ways to track the usage and how people are using it, kind of to compare it with the previous versions of it, right? There's quite a bit of things that are involved right now. And pretty much all the way through, we have to somehow figure out a way to see what's going on with the system. And this is what, we are going to talk about. So for the last 2 years, we have been working on AIM as an experiment tracking tool, and it has given us a chance to work with quite a number of teams who have been building end-to-end kind of AI applications. Some of them have been building with the LLMs, some of them have not been building it with LLMs. But these are kind of the cluster of 5 kind of, it's not all, but the kind of 5 kind of things we thought like are a lot of the teams kind of require from their observability when it comes to building their AI infrastructure. At the base of it is track anything from anywhere, right? If you're building any kind of AI system, sometimes you may start like a subset of it. If you're an engineer getting started building your first AI system, you probably know a lot about fine-tuning prompts, LLMs, right? But if you're a data scientist who have been building AI for the last 5 years, you probably know quite a bit about model, training, etc., right? So there's quite a bit of places we have to track kind of stuff from to be able to observe. So for that, we need to be able to track anything from anywhere, right? Because those systems may live in different places, because your models get trained on the GPUs, but your prompt engineering doesn't need to happen on the GPU environment, right? It could be different parts of the pipeline. But another thing what we have seen is that once the teams that building these AI systems grow, or once the requirements of the AI systems grow, there is lots of needs for customizations. For instance, if you may start simple, like for instance, you may start just building a basic model and deploying it. That would be like, 1 or 2 step, operation. And once that works out as like your company, then you hire more data science, and you hire more engineers. Oh, and then like 2 years later, you end up also combining LLMs to that whole process. So there's a lot of different pieces to this. And then what usually happens is people want to see the track data from many different angles to be able to quickly iterate at the core. And so you want your observability or like your visualizations to be, and the type of data you track as much customizable as possible. So and then another thing that we have seen, people want to automate a lot, right? You want to that's the core of the thing that you track is pretty much enables a lot of these kind of decisions you make between those nodes. Right, so a good number of them can be automated. Or if the loss is, less than XYZ, do this. Don't go to eval, retrain or something. Right, there's lots of area for automations. And then kind of the top 2 main features that are like really, really impactful going forward, which is the core of the kind of AI system, is like the lineage and the governance, right? You want to like pretty much end-to-end see what happened to your machine learning, to your AI system, whether you have started from pre-processing or from prompt engineering, but you still want to see what happened end-to-end. Where did you start? How did you start? And what happened? And then you want to track pretty much everything on the way so you can like precisely know this is what happened. We compare it to the previous versions, and then risk mitigation, because these things get deployed on a bunch of places where we need responsibility, right? Safety and all that. So all of this kind of pretty much gets reduced, what we have seen, to logging stuff and tracking stuff about your different parts of your AI system. So with that in mind, with these kind of 5 requirements in mind, what we have seen, the current state of the kind of observability is we see a lot of solutions that are like, targeting specific kind of boxes, or like verticals, right? And they're kind of mainly, they're kind of by definition fundamentally not interoperable. And so they don't really talk with each other. So you cannot track anything from anywhere into one place, because you are going to use a bunch of different tools for a bunch of different kind of use cases across the board. You're not going to, most of them are not open source. They're all closed source kind of platforms. So it means you don't know the data format, you don't own the data format, it's not an open data format with all its implications. Because a lot of the systems kind of are built around this kind of to track data. So, and besides that, obviously, this means like you're going to have a hard time constructing the lineage. If you just buy into one kind of platform with the lineage, then it means a vendor lock-in, and quite a bit of companies cannot really afford that. So, so this is why what we see is kind of not working with the current ecosystem. But every time I think about like the AI system observability, the kind of question I ask, like, what happened with the software logging? What's the difference between like software logging and the AI system observability? Why don't we use software logging stuff that we have been building for the last, 10 years for observability? If we do a little bit of a historic detour around the kind of path we have taken from software 1.0 to where we are, like the basic software 1.0 logging is, I know this is a controversial term, like, versioning code is not necessarily a logging, but it's a way to kind of track something about your software that then you can attribute back, right? So code versioning and then regular, log files, right? This is one of the ways you can at least test if something went wrong, go and identify, go and fix it, right? And then a little bit more complex software 1.0 situation, you have then multi-node, like staging environments, right? And still you have to version your code. But when it comes to the kind of systems that the AI systems are, the big thing that changes is the code stops describing these systems. In the software 1.0 situation, code this deterministically really describes your system. When you change the code, you expect the changes to happen in the software in a 99 out of 100 times in a very deterministic fashion, unless you make a bug, which all of us do, but yeah, hopefully we don't, right? But that's not so true with the AI systems, because changing the code in AI system doesn't really necessarily deterministic, because you have to do lots of experiment, trial and error, and this is true across the board. This is not true just like for the development, this is true across the board. So these systems are inherently non-deterministic. So what does that? That does add like an exponentially complex situation here, because it's not just one node, it's a bunch of nodes. You have to track your development, you have to track your model training, you have to figure out a way to combine them. So in development, and actually, this is the first time we use the most expensive hardware for development as opposed to for production, right? The GPUs. So another thing. So there's a lot of, and so pretty much, which means like we have to think pretty more deeper about the logging in general of software, because AI is still a kind of a software at the end of the day, right? And so that pretty much brings us to our work on AIM. So we this morning launched the latest version of it. It's a major version. It turns AIM from experiment tracking into an operating system for logs, and I'm going to kind of share it what it means, because it's a little bit of a pretentious name. I do accept that. So pretty much there are like 3 main features around AIM. Logging apps, we will dive into that. Explorers, so explorers are a way to compare like a ton of homogeneous type of logs. If you want to compare lots of metrics, you use explorers. If you compare lots of text sequences, you use explorers, or image sequences, any sequences. That's what the explorers are for. Reports are a knowledge base on top of which your logs or your track data, right? To kind of make sense, connect the dots, fix somewhere, or like insights, etc. And so as part of this talk, we're going to focus on the apps. So those 2 features were just to mention. So it turns out to be we have been using these types of apps all along, pretty much. So we use kind of with or without knowing them. Because if we are using an experiment tracker, it's a kind of a logging app. If you're using a production monitoring tool, it's a kind of a logging app. What makes a logging app? Anything that results in you tracking a bunch of sequences of some kind of an object, which you need to observe and then potentially automate, it's kind of a logging app, right? So there's a bunch of logging apps that we have been using as part of the AI infrastructure. And so what makes AIM an operating system of logs is AIM enables you to build a logging app, distribute a logging app, combine a bunch of different logging apps together and run them together. So this is kind of what brings us into the modular observability of AI systems, which means, you can build the Legos for as wide as you need for your infrastructure. Okay, let's dive into what the logging app means to kind of, one more layer deeper. So there's like pretty much 3 kind of different components of the way we see the logging apps are. And this is based on a lot of the interactions we have had with teams who are building any sorts of AI systems. So logging. So logging means there is a ton of different things that you need to track about your system. So there's lots of primitives like metric, text, images. But then there's lots of other things that for instance, image with a specific JSON, image with a specific audio, or image with a text, or image with a text with a JSON. Each of them could have a meaning in your specific case differently, because depending on the type of data, depending on the type of problem you're solving. So there is lots of stuff to be defined when it comes to logging, because you want to be able to log as much stuff as possible from your infrastructure. And so we provide an SDK to define anything that you want to log. It's at the fundamentally like what AIM is. AIM is a schema-less storage that can store sequences of any type of Python object in a scalable fashion. It's built on top of RocksDB. So therefore, you are going to be able to define any type of objects and then log them and actually use them in your code to track them as well. And it's just Python objects. And then the second part, once you log your stuff, then you want to see what happens with them. You want to kind of compare them. You want to build kind of views on top of them. And that's where the observability part comes in. The new version of AIM comes with the Pythonic kind of UI SDK, which is pretty much as if you have used Streamlit or anything like Gradio, It's a very like interface that allows you to build a UI on top of the logged data as part of the app. And any kind of UI, and you can as many of them as you want. There's also an M query language that allows you to query all the data into the UI. So it's a little bit of a magic if you use it, because it all works in the UI, but not at the same time. Because you have to do, in this case, like compared to Streamlit doesn't deal with a lot of data most of the time. We deal with a lot of data most of the time. So yeah, so therefore, this observability piece, and then the automations, which is not available yet, but it's in the roadmap. But the automations are pretty much okay. How do you register specific actions around the stuff that you have logged, and how do you trigger them from the UI, trigger them automatically, send you notifications? They all fall into automations. An AIM app can be one or two or three of them. So it's actually represented as a Python package. It could be distributed as a Python package. It could be pip installed and then run by AIM. So I don't have any code examples yet because I wanted to keep this like a high level. Feel free to, we are going to do a bunch of webinars going forward, so join us. Lots of code during the webinars. And so we couldn't help but think about these types of apps for the last 2 years, when every time we would interact with teams, or we would, build anything with the observability. Because we have seen teams build lots of custom stuff on top of whatever they have been using, including the earlier version of AIM. So this is what, we couldn't help but think in terms of this. So why do we need the modularity? Why does this matter? Why do we need to care about this? What happens is when you're building AI systems, if you are, and hopefully, successful in one of the first iterations, things get like complicated really fast, both horizontally and vertically. So what does that mean? So horizontally means when you start your first iteration, you're probably cutting lots of corners and then just building what you need to build in the beginning, right? If that works, then you need to now really build something real. And then all these nodes show up. You have to build a good number of these nodes. So you just no escaping. So that's the horizontal sophistry, which means a bunch of different places where you need to log stuff. Each of these nodes then have the vertical kind of complexity. So you may start with the transformer model with a specific task, but then soon, like in a few months' time, now you have transformer combined with an LLM, with a specialized LLM, and then the agents come in. Then you combine a bunch of different agents together. It gets really complicated, and it's going to get even more complicated going forward. Like, I don't know, OpenAI just released this kind of new fancy and amazing looking. It's definitely complicated one layer below. So that's what it's heading. So yeah, and so the complexity gets introduced inevitably. And so you need some kind of way to really, which kind of going to make you view your system in many different angles as much as possible, which, this is what modularity brings. If you install AIM right now, you're not going to need any of the things that I've just shared with you. It's just a basic app. There's a few apps in there, but it's just very basic. A few lines of integration, and it just works for day one. For day two, the talk. But I've been just sharing with you because that's where the fun starts. Yeah, but just the jokes aside, so. The default installation of AIM comes with the base app, which is all the primitives, metrics, images, and all these different types that you can log, along with a generic logs browsing kind of tool, which is just an overview of whatever you have logged. It comes with experiment tracking, actually a bunch of experiment tracking apps. So if you have a PyTorch Lightning, in your training code, then the PyTorch Lightning app will show all your PyTorch Lightning, experiments. And then if you have PyTorch Ignite at the same time, like some other experiments, all of them will be captured in their apps, automatically and visible. You can compare them through explorers, or you can view them through a separate apps, or they're organize them into experiment runs. It's all available out of the box without knowing all this operating system confusing kind of hoopla. And then the AI system tracing. So the AI system tracing, the long chain tracer, Llama index observability, and I think we're going to add an OpenAI observability to this as well. Cost estimation, and all the regular stuff is going to be all just available. If you feel like there is lots of way to improve, feel free to create an app, share with others, and if it's better than what we have built, we'll definitely include into the default version. So there's lots of apps to be created. There's lots of different like logging apps that really need to be created for us to be able to like really solve what does it even mean lineage in these types of AI system. What does governance mean? There's like we believe apps are one of the ways to formally kind of describe what do they mean. Because you describe the type of data that it logs, you describe the type of interactions or like the relationships, and then you also describe how to look at it. You can also describe the automations around them. And that's just the lineage or the governance. But then any intersection of integration is a new app that you can build or use that somebody has built. It's all pip installable. These are all Python packages. Yeah, so we launched it today. Super excited. That would be it. So yeah, and our mission is to really democratize the observability, like really, really democratize, because we enable building logging apps. Thanks so much. Yeah, there's one question. Yeah. Sure. Yeah. So Longsmith is an example of a logging app, basically. But it's for long chain. But what if you use some other tool that's not long chain? Yeah, closer to the mic. What if you use some other tool that's not long chain? Yeah. What if you use long chain with some other tools that are, like how do you track the end side of the long chain, app, like the usage of it? How do you combine them to the, so. Yeah. Well, not AIM, those apps. We are iterating, going to iterate over them. So it comes like with a very rich, like we have built a whole UI kit to enable, any kind of UI you build is going to look good. So we have built a UI kit that enables that, which means we are going to make a lot of these kind of UI components more and more and more. Like for instance, like we don't have a cascade at the moment, which is some parts of the long chain kind of you see. We do have another way of visualizing it right now, but the cascade will be added. It's actually a day's work of kind of task, but things like that. So the core is like how do you take the data to the browser and make it a Pythonic and then make it like easy Pythonic and make it available if you want to. So that's the core part, which is what we have launched today. Yeah. There's a bunch of standard formats out there. So each standard format is also an app. Like if you want, we will, so all that stuff will be on demand. Everybody's welcome to implement those, hookers. If there is a format that you would want to like insert into AIM, it's an app. Feel free to create one. It will be just a logging aspect of the app, where you can just create a logger and then, it will run, like it will be like a small script that runs and then just saves everything into AIM and then everything is available into AIM. You can also create a visualization on top of that too. Yeah, but I think some of the when it comes to OpenTelemetry, some of the basic formats, I think we will end up implementing ourselves anyway. So AIM is open source, and it's all on your premises. It's like a magic library. It comes with the backend, with the storage, with everything. There's two ways to deploy AIM. You can deploy it remotely, which means you can deploy it on like EC2 instance or some other server. And then you can also deploy it all in one place. And then I think going forward, we're going to enable like a multi-user version that's going to be a paid version. It would be source available, but not open source. But it would be pretty cheap. And then it will be the enterprise version as well for like teams. Yeah, but the current aim is like one project, the open source, one project, one user. Yeah, go ahead.
More of a philosophical question. As you continue to scale, how do you think about, I guess, how will your operating sort of work in, say, like a DevOps environment, or also in specifically for AI, the whole tool chain kind of concept of cycling what is coming out of your observability into
Right.
your product.
So the Docker image is already available, and then there's going to be a Kubernetes deployment guide as well. It's not there yet. We used to have the previous version of AIM. We just need to migrate it. In the next few days, it will probably pop up in the documentation. So to start with, I don't know if so usually it's mainly kind of user driven. If their users, open issues, we tend to respond if it's within the roadmap. So there's another question. Oh, the ML flow is an end-to-end model registry, workflow orchestration, right? Type of product. That's not what we do. We are a logging tool. We log stuff, and that's what we do. Oh yeah, on that end, yeah, we probably will integrate with. We already like the early version of AIM does have an integration with ML flow. It just kind of hooks into ML flow and reads just that log part. So it kind of, we like to think of more extending ML flow than like replacing it. We are actually huge fans of ML flow ourselves, so
You mentioned, so you can deploy into a cloud instance, but then you said the other one where it's all one thing. And then I guess that means like you could deploy it as a executable thing in your own stack.
yeah. Yeah. So there is a remote server. So at the fundamental level, there is the way like underneath it works. It's it's a server. So anything you write is through a server. So you can deploy that server somewhere else, and then just push it through like the URL. If you deploy it locally, and then you just need to give it a kind of folder location, pretty much where the data gets saved. And then if you deploy it somewhere else in like a remote server, then you can just give it the URL or whatever is in your infrastructure. So to push it to. Does that answer the question? Yeah. Yeah. There you go. Thank you so much.